Problem 2. Xavier and Zach start from the 2 points A and B and start moving at the same time. If they go in the same direction, same direction meaning this is A and this is B, right? This Xavier is here, Zach is over here. And if they go the same direction, meaning if they all go this way. And we know it's going this way because it says it takes Xavier 26 minutes to catch up to Zach. In this case, this is a catch-up problem, right? Because Xavier, so Z has a head start on X, and X is trying to chase after Z. So we also know that Xavier is faster than Zach, so that's one thing. If they go opposite directions towards each other, it takes them 6 minutes to meet. So if opposite directions, it's if, 2 points and they go towards each other and they're meeting each other, it's a meet-up problem. And this is using the 2 formulas we learned at the beginning of the last video. It takes them 6 minutes to meet. Zach moves at a speed of 50 meters per hour, so we know the speed of Zach. Find the distance between A and B. We have all three, we have 2 values. We have 2 types of values. We have a speed, and we have some times. So let's first write some functions that's going to help us in some equations. So we're going to turn this into mathematical symbols. So 26 minutes. For the first scenario, that is the time. And 26 minutes times the speed of X plus 50, because that's the speed of Zach, remember, is equal to AB. Because in this case, the difference between Vx and 50, and that's equal to AB. Because in this case, this is a catch-up problem, right? And this is the formula for catch-up problems. It's that the time times the difference in speed, and that's equal to difference in distance. And I say difference, and you can also think of it as just the head start that Zach was able to have. And we also have another one, and that's the scenario 2. In this case, 6 is the time. But this is a different type of problem because it's a meet-up problem. 6 times the sum of Vx and 50 is equal to AB, which in this case is a total distance. So since AB equals both this and it also equals this, let's just substitute AB with this value right here. So I'm going to move this up right here. And now we can solve for Vx. Because after we know Vx, we can just solve for the distance between A and B, which is AB. Let's first use the distributive property. 26 Vx minus 1,300 is equal to 6 Vx plus 300. We combine like terms and we get 20 Vx is equal to 2,600. So then 1 Vx would be 2,600 divided by 20, right? And then that gives us 130. So Vx goes at a speed of 130 meters per minute. This is supposed to be minutes, sorry. 130 meters per minute. Now let's substitute this back in whichever one of these we like. I'm just going to use the second one because it seems simpler to me. So if this is 130 plus 50, is 180. 6 times 180, that gives us 1,080. So the distance between A and B would be 1,080 meters.